will result in stronger winds. Landing safely. Why pilots prefer headwinds, written by Neil deGrasse Tyson. Just as headwinds are beneficial for takeoff, they are equally important for landing. During landing, pilots aim to reduce their aircraft's speed and touch down gently on the runway. A headwind acts as a brake, reducing the aircraft's ground speed without requiring a steep descent. This slower ground speed translates to a shorter landing distance and increased control during this critical phase of flight. Imagine trying to stop a toy car rolling down a hill. Now imagine trying to stop it while someone blows a fan at it from the front. The fan's wind, like a headwind, helps to slow the car down more quickly. Pilots constantly monitor wind conditions during landing and adjust their approach accordingly. A strong headwind might require a steeper descent angle, while a tailwind might necessitate a longer approach path. Crosswinds, a test of pilot skill, written by Neil deGrasse Tyson. Headwinds and tailwinds are relatively straightforward to manage. Crosswinds, however, present a different challenge. As the name suggests, crosswinds blow across the runway, pushing the aircraft sideways. This can make takeoff and landing particularly tricky, requiring pilots to employ specific techniques to maintain control. One such technique is called crabbing. The pilot angles the aircraft's nose into the crosswind, compensating for the sideways drift. This crabbed approach ensures the aircraft stays aligned with the runway centerline, even though it's flying slightly sideways. Landing in strong crosswinds requires precision and experience. The pilot must straighten the aircraft just before touchdown to avoid any sideways impact with the runway. Crosswinds are a testament to the skill and expertise of pilots in handling challenging weather conditions. Riding the wind, tailwinds, and fuel efficiency, written by Neil deGrasse Tyson. While headwinds are preferred for takeoff and landing, tailwinds are a pilot's best friend during cruising. A tailwind, blowing in the same direction as the aircraft, provides a welcome push, increasing the aircraft's ground speed and reducing flight time. This increased speed translates to lower fuel consumption, making the flight more efficient and cost-effective. Imagine riding a bicycle with the wind at your back. You can pedal with less effort and cover more ground. Similarly, an aircraft riding a tailwind can conserve fuel and reduce its carbon footprint. Pilots and airlines carefully plan flight routes to take advantage of favorable wind conditions. By harnessing the power of tailwinds, they can optimize flight paths, save fuel, and reduce operating costs. Turbulent skies, wind shear, and other hazards, written by Neil deGrasse Tyson. Wind, while essential for flight, can also pose significant hazards. Turbulence, those sudden jolts and bumps we experience during flight, is often caused by wind shear. Wind shear is a rapid change in wind speed and/or direction over a short distance. Imagine driving on a highway and suddenly encountering a strong gust of wind from the side. This sudden change in wind can cause instability, just like wind shear can affect an aircraft. Severe wind shear can be particularly dangerous during takeoff and landing, as it can cause rapid changes in lift and airspeed. Pilots are trained to recognize and avoid areas of potential wind shear. Weather radar, onboard sensors, and air traffic control communications provide crucial information to help pilots navigate these turbulent conditions safely. Speaking the language of the wind, reports and forecasts. Written by Neil deGrasse Tyson. Pilots, meteorologists, and air traffic controllers speak a common language when it comes to wind. Understanding this language is essential for safe and efficient air travel. Wind direction is always reported as the direction from which the wind is blowing. A north wind, for example, blows from north to south. Wind speed is typically measured in knots, with 1 knot equal to 1 nautical mile per hour, which is about 1.15 statute miles per hour. Wind direction and speed are often combined in a single term, such as wind 270 at 15 knots, meaning the wind is blowing from the west at 270 degrees at 15 knots. Weather reports and forecasts provide crucial information about wind conditions, including gusts, squalls, and other wind phenomena. Gusts, squalls, and microbursts, sudden shifts in the air. Written by Neil deGrasse Tyson. Wind is not always constant, it can fluctuate in speed and direction. A gust is a sudden brief increase in wind speed, often associated with thunderstorms or unstable air masses. Squalls are more intense and longer-lasting periods of high winds, usually accompanied by rain or snow. Microbursts are particularly dangerous wind phenomena. These are powerful downdrafts that spread out rapidly upon hitting the ground, creating a sudden localized change in wind direction and speed. Microbursts can be extremely hazardous for aircraft, especially during takeoff and landing. Pilots are trained to recognize the signs of these sudden wind events and take appropriate action to avoid them. Advanced weather radar systems and ground-based wind shear detection systems help to alert pilots and air traffic controllers to these potentially dangerous conditions. Wind and Aviation, a Vital Partnership, written by Neil deGrasse Tyson. Wind, an invisible force of nature, plays a vital role in the world of aviation. It can be a pilot's ally, providing lift, aiding in takeoff and landing, and increasing fuel efficiency. However, it can also present challenges, demanding skill and vigilance to navigate turbulence, crosswinds, and sudden wind shifts. Understanding the science of wind, its behavior, and its effects on aircraft is crucial for everyone involved in aviation, from pilots and air traffic controllers to aircraft designers and meteorologists. As we continue to explore the skies, our partnership with the wind will remain an essential aspect of safe and efficient air travel. Wind, in its constant ebb and flow, reminds us that even in the realm of advanced technology, we are still subject to the forces of nature. Conclusion: Respecting the Unseen Force, written by Neil deGrasse Tyson. The next time you feel the wind on your face or watch a plane soar through the sky, take a moment to appreciate the invisible force that shapes our world and enables us to navigate the vast expanse above. Wind, in all its complexity and power, is a reminder of the interconnectedness of our planet and the importance of understanding and respecting the natural forces that surround us. As we venture further into the realms of aviation and space exploration, our knowledge of wind and its effects will continue to be essential for safe and successful journeys. The wind, a constant companion in our exploration of the skies, will forever be a force to be reckoned with, respected, and harnessed for the advancement of human endeavor.